Alrighty, here's question number 6. Given g of x is equal to, we have 3 different pieces here. X cubed minus 2x plus 2 is when x is less than or equal to negative 2. And then we have x squared plus ax plus b, and 4x fourth minus 3x cubed minus 5x plus 2. So this is an example of a piecewise function. The reason why it's called piecewise is because it's a function broken up into pieces. So you'll see that we have it into 3 different pieces here. It says to find values for a and b so that the function is, here's a keyword, continuous for all of x. So I'm looking here at my piecewise, and I see that a and b is only where my green is at right now, a, b. That's what I'm looking for. And they tell us, here's a vocab word, continuous. Continuous meaning that if I were to connect my pieces together, so let's say I were to graph this, I'm just gonna sketch, like let's say I graph the yellow, and then I graph the green, and then I graph the blue. So if I connect all the pieces together, it should be continuous, meaning that if I were to put a pencil on the left side, without lifting up my pencil, I should be able to go through the entire function because it's continuous. If this were a graph, you'll see that we want to know this exact point and that exact point. But you'll see here that to transition from yellow to green, the x coordinate is -2. That's where they're kind of switching off, going from yellow to green. So I know that the x is -2. From green to blue, you'll see that the x value is 1. I don't know what the y coordinate is, but the x coordinate, that's where we're kind of handing it off from green to blue. So our goal is to figure out what is this green function. So to figure out what this green function is, it really helps us to know what goes into this y coordinate. We're going to do that right now. So for the yellow piece right here, I'm going to plug in -2 to figure out what my y value is. So let's start with that. Let's plug in -2 into my yellow piece. Then I plug in. And then I get 8 plus 4, -8 plus 4 plus 2. I get -2. So now I know that this point is -2 comma, excuse different color, -2. You'll see that's the point I got. Which means if this -2 existed to connect the yellow and the green, even the green one must have this point, -2 comma -2. So I'm going to go over to the green one now and also plug in -2. -2 squared plus a, -2 plus b. Then I get 4 minus 2a plus b. So you'll see that we're really stuck with this a and b, but I know that whatever a and b is, ultimately it has to equal to the -2 that we obtained, because if we put -2 into green, it has to be at that same point as this yellow one because they're handing it off. Once again, it has to be continuous. So they're meeting at a certain point here. So this has to equal -2. I guess we can simplify this equation here. So we have -2a plus b is -6. And this is an equation we have. You might think, Miss So, how do we find a and b? We don't know yet, but this is an equation we're going to use later. So I want you to know that we were able to build this equation with a and b just using this point right here, the point connecting the yellow piece to the green piece. We're going to do the same exact thing what we just did, Instead, now we're going to look at the point that's connecting the green to the blue. So let me just zoom out. I'm just kind of draw a line. So now we're going to do from green to blue. So here we see that the x-coordinate that's connecting the green piece to the blue piece is 1. So I'm going to plug in 1 to the green equation first. So it's g of 1 is equal to 1 squared plus a 1 plus b. Let me just double check I wrote all of that correctly. Yes, I did. So I get 1 plus a plus b. I don't know what it's supposed to equal to yet, but I can soon figure out using the blue one, because the blue one doesn't have any a or b's. So the blue is g of 1. So once again, we're going to use the same one for the x-coordinate to see what connects the green and the blue. So we have 4, 1 to the 4th power minus 3, 1 to the 3rd minus 5 plus 2. Just double check I wrote it correctly. Okay. Then I have 4 minus 3 minus 5 plus 2. Then I have negative 2. Which means, because when I plug 1 in, I got negative 2, that means this point is at 1 comma negative 2. Let me just make it black ink. So if I were to go back here, this is 1 comma negative 2, transitioning from the green to the blue. So since this point is 1 comma negative 2, it means that if I were to go back to this green equation, it has to equal to negative 2. And then now I can get this equation here, and then I'm going to simplify by subtracting 1 to both sides. I have a plus b is equal to negative 3. So you'll notice here I have one equation earlier with a and b, and I have another one with a and b. I have 2 variables and 2 equations. I can solve for this. So let's bring these 2 equations down here. I'm just going to change it to pink. Now let me just put pink stars so you see that. So I have negative 2a plus b is equal to negative 6. A plus b is equal to negative 3. Starting from here, it's really up to you. You can use elimination or substitution to solve for this. I personally, I personally like substitution. But once again, it's really up to you. I'm going to change this equation here. I'm going to subtract a to both sides. Getting b is equal to negative 3 minus a. Now using this, since b is equal to negative 3 minus a, I'm going to substitute it to that equation. So it's going to be negative 2a plus, instead of b, I'm going to substitute the negative 3 minus a equals negative 6. Then I'm going to combine like terms. Negative 3a minus 3 is equal to negative 6. Add 3 to both sides. Negative 3a is equal to negative 3. A is equal to 1. Whew, we found one of them. And then I want to find b. So since a is equal to 1, I am going to get this 1 here and substitute it. So you'll notice I'm using substitution strategy because I substituted the b for this, and now I'm going to get this a equals 1 and substitute it here. And then I get b is equal to negative 3 minus 1, b is equal to negative 4. And then those are my 2 answers to make this piecewise continuous.